doing a substitution in the second position, we have to examine also the intermediate. Okay, this is addition, and then the intermediate is now I will try to stabilize this negative form using resonance. However, any resonance that I am doing, basically I am disrupting the aromaticity in the fused benzene ring. As I told you a lot of times, every resonance form that is disturbing the fused benzene ring doesn't count at all. It's very unstable. That means that when I am attacking at this position, basically I only have one resonance form. While in the other position, if you remember, what I have is two resonance forms. Here I have two resonance forms that the aromatic benzene ring fused to the quinolide, the isoquinolide, is intact. Here I only have one resonance form. That means that this will be the preferred position to attack the methoxide, because the intermediate is more stable because he has more resonance form. Okay? Good. Then go for the next exercise, that is the starting of the part B. In this exercise, we will play with our previous knowledge. Okay, it's a reaction that we never saw. We have this compound. We add iodide with sodium bicarbonate, and what we get is the thiophene with this substitution. We never saw this reaction to form thiophenes, but we can play with our previous knowledge, as I told you. We add iodide. Iodide, we know that is reacting with double bonds, to form the iodonium ion. But basically, we can do the same here. That means that triple bond is reacting with the iodide to form this intermediate. This iodonium ion. Okay? And now what is happening? Well, basically, we know that this iodonium ion is very reactive, and this can react with, basically with a nucleophile. The nucleophile will open the iodonium ion to form the iodine species. I mean, which nucleophile we have? We have a very good nucleophile with the sulfur, attacks here, and then the iodonium ion is opened. Why here? Well, we have to form a stable member ring. We have 1, 2, 3, 4, 5 member ring that is stable. That means that this will lead to this compound. Okay? And now simply what we can do is an elimination. Okay? We can do elimination of this OH. The base is taking this. And basically what we are doing is a E1CB elimination. Why we are doing E1CB elimination? Because this hydrogen is very acid. Why is very acid? Because when we deprotonate this hydrogen, this compound becomes aromatic. And this is how we synthesize this thiophene. Okay? Good. Then we go to exercise 4. Okay, we start with this compound. And the first step is we add acetic acid, aqueous. And the most important of this exercise is the aqueous. Why? What is this? This functional group here is basically an acetal. That means that what we are doing is breaking this acetal to get the ketone and the alcohol. Okay, remember how it's working this? First, we protonate, okay, and then basically this is eliminating. We do the elimination to generate the oxonium ion. Here we can see the oxonium ion. Okay, and then a molecule of water. Whoops. A molecule of water is attacking this oxonium ion to generate this hemiacetal, and another protonation. Now of this oxygen. Okay, again elimination, and what we do is to generate that we remove this proton, this and all we transform in the ketonic form, and we generate this compound, this ketoaldehyde, that is the product B. Then what we are doing is add hydroxylamine with chlorhydric acid, and here what is happening is basically we form the iminium here. Okay, we form the oxime. Okay, when we have the oxime, basically this can form the enamine, tautomerization to enamine. And then the nitrogen attacks again now to our carbonyl. Why attacks the carbonyl? Well, we have to, here we have several options. Also can be that the wedge is attacking the carbonyl, but if we have to check which cycle we are forming. 1, 2, 3, 4, 5, 6. That means we are forming a 6-member ring that is very stable. If we attack with the wedge, we are forming a 7-member ring. And remember, one way to synthesize pyridines is with N-oxides. With hydroxylamine. Okay? we do this and we get this intermediate, and again tautomerization imine enamine to form the dihydropyridine. Okay, and remember that this dihydropyridine is very unstable, and what we are doing is basically we eliminate the wedge to form the final pyridine. Okay? That will be C. Okay? Good? Next one. We have this compound. And we want to synthesize this. How we can do it? Okay. Always when we are doing a reaction, we have to count the number of carbons. Here we have 1 carbon or 7 carbons, and here we have 1 carbon more. And this carbon is functionalized with an amine. That means how we can do it is, we have 2 options. We can use nitromethane or we can use cyanide. For example, if we react this with cyanide, what we are doing is we generate this intermediate, and then we add lithium aluminium hydride, and we get the final compound. Okay. Cyanide we can use, for example, soluble cyanide in the MSO, and then lithium aluminium hydride. Then with this compound, what we do is we add this acid chloride, okay, with triethylamine as a base. Basically, this is the typical condition to form an amide. Okay, and then we add POCl3. Basically, we are converting this compound this, and then intramolecular electrophilic aromatic substitution to generate this intermediate that is compound number 3D. Okay, if we want to get the aromatic, the only that we have to do DDQ, and we get the aromaticity. Okay? Right? Okay. Then we go for the last one. We have this compound. and we add acrolein. Sulfuric acid heating. Okay, what is happening is that basically what we have is a Michael addition. Here we generate this intermediate. Okay, and then intramolecular electrophilic substitution. Remember that this ring is very active, and what we get is this aldol that after elimination give us this dihydropyridine, and then simply nitrobenzene. Air we oxidize to generate the aromatic compound. Okay? This is how it's working. Basically, it's a synthesis of quinolines. And then they say that in practice, instead of acrolein, what we are using is glycerin. Glycerin is this. Okay. This in acid, what is happening is that basically we protonate, we generate this, okay, this eliminates, forming this compound. This compound is not any more than enol. That means that we can grow it also in this way. And then a second elimination. Give us the acrolein. Okay, basically it's two eliminations together. And this is all for the tutorial. This is the last tutorial of the course. If you have any question, please send me an email and we can arrange a meeting in Teams or in Blackboard collaboration, okay? Or I can answer directly by email, okay? Thank you very much and see you soon.